Welcome to Easy Math TV. We have another tutorial here in our business math series. This time we're going to show two graphs. We're going to make two graphs of two types of exponential formulas, exponential equations. And one of them is going to show us exponential growth. The other one is going to show us or demonstrate what exponential decay or decline looks like. So there's two equations. The first equation is y equals 3 to the x power, and the second equation is y equals 0.75 to the x power. And the directions say to use x in bracket 0, comma 8 bracket. So just to remind everyone, when you see a square bracket like that, it means that that is an interval, and the interval of x values starts at 0 and it ends with 8. So as you can see in our table, we've identified our x values here in column C. X starts at 0 and it ends at 8, and I'm just going to hit all of the integer values in between those two values. So starting with 0, ending with 8. And also, as you can see in column B, we also have our delta x's are constant. So we're going to get to see what the exponential growth pattern or the exponential decay rate is. We're going to see what that is over here in column F. All right. So we're going to get that as a bonus in addition to just graphing. Also, just to point out that sometimes your function might be given to you as a fraction to the power x. If that is the case, you need to put parentheses around that fraction up here in the cell. So when we get to the 0.75 one, I'll show you what I mean by that. Because fractions and decimals, you can see it interchanged, partly because of the fact that some fractions have a repeating decimal, and you don't want to truncate that decimal. You don't want to shorten it. So sometimes you actually have to use the fraction. All right. Anyway, so let's do the first one. Let's do the y equals 3 to the x. Okay, so up here in cell D2, you're going to type equals, and then the base, we call that the base 3, and then you want to type in a caret. That caret symbol tells me that I'm now about to type an exponent. And the exponent is in cell C2. That is my value of x. So again, that's equals 3 caret or exponent C2, and hit enter. And now select the anchor in the lower right corner and fill down. And as you can see, the y values are getting pretty large. This has a pretty significant rate of growth here. Let's calculate our delta y's and our delta y divided by y, and then we'll talk about the graph. So in column E, delta y is going to get the first value of delta y will get calculated in E3. So type equals, and that's going to be D3 minus D2. Hit enter, and again, click on that anchor in the lower right corner and fill down. And now we're going to do a slight change here because this is going to give us our actual rate of growth. So we're going to take our delta y that's right next to this cell, that's in E3, but instead of dividing by the y value that's right in the same row, we're going to divide by the y value that's right above it. So we're going to divide by D2. That's not going to change the fact that column F is still going to give us numbers, like a constant. We will still see that constant pattern, but we will be able to interpret this value as our growth rate. Okay, it's equal to our growth rate when we take our delta y from this row and divide by the y value from the previous row. So that has to equal E3/D2. And I have this entire column here is configured as a percentage. So if you didn't already do that, you want to make sure that you have it as a in style, that it's styled as a percentage, okay? Because otherwise it's really hard to read. It's much easier to read if you have it styled as a percent. Again, click on that anchor in the lower right corner and fill down, and you see that we get the same number all the way down. Delta y divided by y. And it's delta y divided by the previous y value. So that is our growth rate. It's not 20%, it's not 2%, it's 200% growth rate. So basically the population, or the amount over here, is tripling every single time. You're getting 3 times the amount, the previous amount, every time, because it's the amount, it's 100% plus 200%, or 300% in total. So let's look at the graph. Insert scatter plot with, let's do scatter plot with smooth lines. You have your choice. You can either do just smooth lines, period, or you can do smooth lines and markers. That'll show you your points. That might be a good choice in this case, because the first couple of points actually look like they're just 0 because they're so small. They're so small they might as well be 0, but they're not. They're just very, very small numbers that you don't see it on this graph, because this graph goes all the way up to 7,000 on the y-axis. So when the y-axis gets pretty big, any small values of y are going to look like 0. But this is your graph between x equals 0 and x equals 8. You just need to be careful not to have this blue line touch the x-axis. You kind of want it to be just above it. Like, you want to be able to see the x-axis and the blue line at the same time, because it never quite hits 0. And if you want to see that a little better, you could just graph this for the first, say, x equals 0, 1, 2, and 3. So we could go over here and we could just select those points and go to the same, insert the same kind of graph here. And there's your first 4 points, and you can see that it's not quite 0. But it is demonstrating exponential growth, and this is significant exponential growth when it's increasing by 200% every single time. So that's your growth rate. Your growth rate is 200%. Your base B, which is 3, tells us that the amount every time is going to be 300% of the previous amount. That's your total amount. That's not your increase. That's not your growth rate. So the number 3 is really 300%, which is 100% plus 200%. Okay. Okay. So let's tackle the second one. So let's go up here and clear these out. I'm just clearing the contents. And now, so in cell D2, we're going to type equals, and if we wanted to use the fraction, we would have to put parenthesis, 3/4, close parenthesis, caret x. I mean, sorry, not x, caret C2. Man, because your x value is in cell C2. So equals parenthesis, 3/4, close parenthesis, caret C2 is the same thing as if we had just typed 0.75 here, caret C2. But make sure that you put the equal sign, because you're telling, it's important that you tell Excel when you've got a formula that you want it to calculate. So fill down, And now we see that our delta y divided by y's are negative. You see that? Because delta y is decreasing. The y values are decreasing, so your delta y's are negative. So that means your delta y divided by y is also negative, which tells us that our rate of decline is 25%. It's 25% decline. So, and the reason why it's 25% is because the base 0.75 is 1 minus 0.25. So that's the way you get that is 100% minus 25% is 75%. Okay, what you end up with. Okay, so let's see a graph of this. And there's your graph. You can add a chart element, by the way. You could actually put your data labels on. We could put the data labels above the curve. So those are your y values there. We could format them. We could format them so that it actually shows the x value as well. You know, and you can even move them around if they're kind of getting in each other's way. You can move them around so that they're not in each other's way. Kind of like this. Just move them around as you need to, because then you're going to make an image of this. You can make a picture out of this. So once these points start to get kind of close together, we can, you know, move them around as the labels, that is, move these labels so that they're not bumping into each other so much. I'm going to move this one below. I'm going to kind of alternate it so that they're that one's going to go below and this one's going to go above. There, so that's a little more readable. It just doesn't have parentheses around the coordinates, but you know, those are your ordered pairs that show what each point on this graph is. Okay, so those are now labeled. You could also, over here, right now, we could just reduce the number of decimal places that are showing, and that will adjust on the graph as well. So the number, if you change it over here, it'll change on the graph as well. Okay, so you know, there's your graphing of an exponential decay situation where we have the base of the power x is a number smaller than 1. So that's going to give us decay or decline. Like, subscribe, comment down below, share these videos with people that you think might find them useful, and I'll see you in the next video.